From New York to Miami, Lagos to Shanghai, people face a sobering threat. Because of climate change, the places where hundreds of millions of people live, by 2050, are likely to be underwater.
A big crisis that's looming is how we're going to deal with this future.
Today, scientists are racing the clock, trying to help us prepare for what's coming before it's too late. From villages to towns and big cities, people have always lived right by the ocean. But today, these low-lying coastal areas are in jeopardy.
The base of the cliff now is somewhere in here. It's now been reinforced by concrete, but 20 years ago, it was probably another 20 meters further seaward.
Geologist Patrick Barnard has spent years investigating the risks to communities along the Pacific coastline of North America.
In some cases, geology is very much about the past and very, very slow changes, but the coast is extremely dynamic. You can see these things happening every single day.
The threats to coastal communities stem from two powerful forces. Both of them are direct consequences of the warming of Earth's climate. First, the oceans are rising. That's because as water grows warmer, its molecules move faster and take up more space. And also because of all the water being added to the oceans, from the melting of the vast ice sheets in Greenland and Antarctica. By 2050, scientists predict that along the US coast, sea level on average will be 10 to 12 inches higher than it is today. That may not sound like much, but on a beach, if today the high water mark is here, just a 1-inch rise in sea level will push it about 8 feet further inland, and a 12-inch rise, about 100 feet. And that's more than enough to cause many places to become partly or completely flooded, including parts of big cities like Seattle, Washington.
Here we are along the Seattle waterfront on the edge of Puget Sound. And this is a very common setting across the world where we have a very large city built right up to the water's edge that has very little margin for error in terms of sea level rise. These lowest lying areas, which are literally just a few feet above sea level, are vulnerable to daily flooding in the coming decades.
But in many places, rising sea level is already destroying people's homes.
This isn't just the next generation's problem or our grandkids' problem. It's happening today. We see sea level rise impacts across the world, and the more sea level rise there is, the more people will be vulnerable.
Hurricane Michael now bearing down on the Florida Panhandle, the most powerful storm ever to hit this part of the Gulf Coast.
Hurricane Ida is still miles away, but this much water this early is not a good sign for the city.
The second threat to our coastlines comes from the storms that form over the ocean. Warmer water is infusing them with more energy, increasing their destructive power.
While storms may happen infrequently, that's when the real societal impacts occur. We can maybe deal with the slow incremental change as sea level rise through adaptation, but if we're still built in this very narrow margin, when these storm events come, we're going to overtop those margins. So it behooves us as a civilization to help protect these communities right now.
To do that, Patrick and his team at the U.S. Geological Survey have developed a powerful tool, a computer model they call Cosmos.
How big the waves are at this location.
It can give communities a detailed picture of the hazards that lie ahead.
Cosmos is trying to identify the vulnerabilities our communities face due to climate-driven sea level rise and storms. It's about 100 different programs that talk to each other, and so we're running on supercomputers. Cosmos can predict what happens if we raise sea level by 2 feet, what happens if the storm magnitude is increased by 10%. And we can start kind of playing these sorts of scenario games to look at the future.
Cosmos enables Patrick to show people just what they're up against.
This is a virtual reality simulation from Capitola to try to really let people know what future sea level rise and storms look like. And you could picture this could be Carpinteria, this could be Pierpont, any of these low-lying beaches in the state.
What makes simulations like this possible is the same basic principle that lies behind most computer models. Using mathematical equations as stand-ins for the forces of nature. Forces such as tides, winds, and waves. To train Cosmos to predict how those forces will affect our future, Patrick and his team started by teaching the model how those forces worked in the past. They fed it lots of data collected during previous storms, and then tweaked the model until it correctly calculated how much flooding actually took place.
If we have confidence in the past, these models were able to simulate reality appropriately, then we can make better projections for the future.
And those projections can only be credible if they are solidly grounded in data. That's why Patrick and his colleagues from the US Geological Survey are constantly collecting new data about coastal forces. Here at Ocean Beach in San Francisco, they're gathering evidence about another threat to our coastlines. Beaches like this one are at risk of disappearing because bigger storms and rising seas are washing them away. For the last 18 years, a team from the Geological Survey has been tracking how the amount of sand on this beach has been changing. Patrick's colleague, Dan Hoover, is leading today's survey.
Ocean Beach is an interesting place because it's really dynamic. They get really big waves here in the wintertime, so it's a great place to study sand movement because it moves a lot. Things are changing all the time. I mean, this is what this beach is about.
To measure the precise height and position of the sand, Dan and his colleagues use all-terrain vehicles rigged with GPS devices. And 2 watercrafts, using sonar scanners, record the amount of sand that's beneath the waves.
This is our 49th survey since 2004. The hope is that what we understand here is going to feed into the models and make them better predictors of what happens all around the country in the future.
Patrick and his colleagues are now expanding the range of Cosmos so that it will be able to make predictions for any part of the US coastline, from the Atlantic all the way to Alaska. But they aren't satisfied with just predicting the future. They are showing people steps they can take right now to help protect their communities.
Here's an adaptation option that you might consider that could really, curb some of these impacts. So we're going to talk a lot about solutions today.
With insights gained from Cosmos, people are developing projects to protect their coastlines by building up sand dunes, installing fences, and planting vegetation that resists beach erosion.
The real reward is in making this information available so people can plan the most effective way for having a resilient community in the future.
One of the many California towns that's using Cosmos is Santa Monica. When Patrick was growing up, he spent a lot of time here on the beach.
I think back a lot to when I was a kid and just enjoying being in this environment and love the sound of the waves breaking, love walking on the beach. And if there's some way I can help protect these communities right now, then that would be a great path for the future.